So we just learned about the principle of transmissibility. So it doesn't matter where a force is applied as long as it acts on its force of, as long as you keep the same line of action through the force. And also that for a force at an angle, you can calculate the moment, but you need to use the lever arm that's the shortest distance to the line of action. So let's just have a look at solving a little problem using those rules. And I'll do it in two ways. So again, we'll use scale drawing. So don't underestimate the usefulness of scale drawings. It can be a really quick way to get a rough value, and it can also be a great way to check your answers in an exam if you have time. And so what we'll do is we'll just draw a free body diagram, simplified free body diagram of this problem. So it's 3 meters, so I'll use 10 divisions as 1 meter to 3 meters. Going to be big enough? Might do it a little bit bigger, so I'll do 10 divisions is half a meter. So we've got 1, 2, 3, 4, 5, 6, so that's 3 meters. So this is 3 meters long. And we've got a force, which I'll just do in another colour so it's clear. It's at 30 degrees to horizontal. 30 degrees and it's 20 kilonewtons. So it's a different scale, it's kilonewtons this time. I'll just do 10, 20 kilonewtons like so. That's 20 kilonewtons. And just where later we'll do by calculation, so I'll just move that out of the way and I'll just write the angle as well. So we're drawing it to scale, so that's okay. So that's at 30 degrees. So where would the line of action be? The line of action would be like so. And we're looking for the shortest distance between A, which I should mark on my diagram, the shortest distance between A and the line of action, which is always going to be the right angle. So you can see at the moment I'm looking at this angle here. That's less than 90 degrees. We need to move that around until it equals 90 degrees. Because we've been given that angle, we can actually figure out what angle this should be. So that's 50 degrees from horizontal. This one's at 30 degrees. So it must be 60 degrees here to get a right angle. Oh. And it's useful just to mark on your right angles. Be handy later when we're doing our calculations. So that's the lever arm for this force. We've found the line of action of the force. We've looked for the shortest distance between that line of action and the point of rotation, and then mark that on. And so now we can just measure what that is. So we had 10 divisions was half a meter, 1 meter, 1.5 meters, half a meter, 1 meter, 1.5. So first way of looking at this problem from scale drawing. Sorry about that. From scale drawing, D is equal to 1.5 meters. And I think because it's 30 degrees that makes sense. So therefore moment is equal to force times lever arm, which is equal to 20 kilonewtons times 1.5 meters, which equals 30 kilonewton meters. Write the answer. So moment of force about A is equal to 30 kilonewton meters. So that's using a scale diagram, but we could have solved this also using trig. So let's have a quick look at how we would do that. So we've got a right angle triangle. There it is, down here, along here. That 3 meters is forming the hypotenuse. What we need, so we've got a side. We want to find this lever arm. That's what we want to figure out. So we've got a side, so we need an angle. So we think about our angles rules. And so what are the different angles rules? Just thinking out loud. So it could be angles in a straight line. Could be the X rule. Could be any of the other parallel lines rules. Sorry, not very parallel. So you know these ones. Could be angles in a triangle add up to 180 degrees. Could be any of those rules. So you kind of got to think through those rules in your head. The one I can see here is we've got 30 degrees here. These two lines make a cross. They make an X, so it's the X rule. So this must also be 30 degrees. So let's mark that on. So that's 30 degrees. So now we're trying to find D, this time by trig. So from trig, let me just, when we're coming back to this later, I'll just say this is, no, it's not really or, you could do both. So by trigonometry, by trig. So we've got angle, this must be hypotenuse, it's opposite the right angle, this must be opposite, it's opposite the angle. So opposite over hypotenuse is sine. So therefore, sine 30 degrees is equal to opposite over hypotenuse. Sine 30 degrees is equal to D over 3 meters. Therefore, D times both sides and swap them. 3 times sine 30 degrees, which with any luck will be 1.5. I think it is. 3 times sine 30, 1.5. So that is 1.5. I just noticed I shut that down, so let me get it opening while we're still working. So 1.5 meters. So then we can use M is equal to force times lever arm. Lever arm is the shortest distance to the line of action. So that is equal to 20 times 1.5, which is equal to 30 kilonewton meters. We would write our answer, moment of force. About A equals 30 kilonewton meters. And so if you were doing an actual question, maybe you'd want to use the trig, so you calculate it using trig, and maybe just at the side you do a check using the scale drawing. Or if you got completely stuck and you couldn't figure out how to do it with trig, then at least try and do it with a scale drawing. That way you can get an answer and you'll get a reasonable mark for that, as long as your answer is near the right value. Okay, so what we'll do now is, that's one way of doing these, is to think about draw the line of action, find the lever arm, the shortest distance to that line of action, and then use trig to figure out that lever arm, or use a scale drawing to figure out that lever arm, and then just use lever arm as force times distance. But there's another way, and so we'll give a little bit of background to that first, and then we'll do this same example using another method.